men. And I use the term loosely. This is my bike, the Project Chopper. This is the swing arm I'm going to use. I'm just doing a general check and making sure that I could get the spanner nut off. In a little bit here, we're going to cut the ears for the shock absorbers off because I'm going to re-weld them in a different spot. But just a couple of heads up. This thing was staked in 1, 2, 3 places. And I took a Dremel tool and just kind of cut into the stake. Cut into the stakes a little bit to remove some metal to, reduce the interference. And we're going to try to get the spanner nut out. I got a halfway decent pair of spanner wrench pliers here. And it's loosening. It might come out. You could just tell the threads are dicked up. Just going to keep working this until it comes loose. Alright, I had to get radical at this one. I was making little or no progress. I tried minor heat with the old map gas torch. Didn't really do much good. I tried my favorite, liquid wrench. Usually this stuff works pretty good, not this time. Kept working it back and forth with the spanner, no good. So I decided to weld the nut to the spanner nut. Let's see how we make out now. Well, I think we're going to get it. Could I have beaten it out of there with a punch and a hammer? Yeah, probably. But this worked very well. And of course, it's hot. It may very well be that the heat of welding did as much to loosen it as anything else. But anyway, going to let this cool off and we'll get back on it. Alright, I wasn't originally planning on doing this. I was hoping these nuts and threads and all that were going to be good enough to, just do some test fitting, but they're dicked up, so it's got to be done sooner or later. May as well start doing it now. Putting a little valve grinding compound on an old nut. This is not the nut that was in there. This is a different nut. And we're just going to work it back and forth until the thread's all the way in. And that feels pretty good. That should just about do it. Alright, I flipped it around and I got the big nut side facing up, and I might have just screwed myself because I ran it in until it popped out the bottom of the socket. There we go, just enough left hanging out to grab it. And this one goes in easy, no valve grinding compound required. So this side is good. And we're going to run a dingle ball hone through there to clear the rust and the crud out. And just a couple of quick strokes. You know, the goal is not to remove material. The goal is just to clean it up a little bit. Flip it around, we'll get the other side. That's all it takes. Okay, whenever I get one of these old swing arms to work on, this is what the bearings and the races look like. Junk. For purposes of test fitting, I'm going to run these through the parts washer and clean them up. Just for test fitting, obviously they're going to be replaced at final installation. Alright, we got the shock mounts cut off of the swing arm. I'll be welding new ones on at a different location later on. But that's what this whole gyration is for, is to figure out where to weld the new ones on. Okay, so here's the bearing mounting area for the swing arm. This has been honed out. The threads have been chased with that valve grinding compound technique. Some of the rough grinding was blended out over here, so this is ready to be assembled, and we're going to assemble it, I guess. Why not, huh? Got a dust shield goes in from the bottom. Got a spacer that goes in on top of that. Got a bearing that goes in. Got a bearing cup that goes on top of that. We're just going to draw it in, and the bottom race removal tool will stop it when it gets flush to the edge, and it'll seat up nicely. Okay, that's it. It's bottomed out. Beautiful. Okay, this bike had a hardtail on it, so there was, of course, no swing arm, and none of this shit was installed. So here's the axle, and it doesn't want to go in the hole real well. So we're going to use a dingle ball hone on it and smooth it out a little bit on the inside. Perfect. All right, the swing arm is just hanging there. We're going to stuff an axle in it. Okay, that's in there. And the big nut for this side. And that's it. So we're going to be able now to use this to test fit the shocks and locate where I want to weld the shock mounts on. That'll be good to go. Swing arms. This one, well, or one just like this, is what came off of the 74 that I'm working on for myself. This one, I think, is off of a 79 or an 80, and this is what I'm going to put on there. Why am I doing this? I like the square tube. It's just so much cleaner. This is just so convoluted. I just, don't like the shape. This must have been a difficult part for Harley to manufacture. You got the forgings back here, this goofy bends in these tubes. I just don't understand it. I got concerns, as a guy should have concerns anytime you undertake something like this. One of the things I'm concerned about is the distance from the shock mount hole, which is right here, and the axle, which would have been back in this area. Because these shocks have this extra leverage acting on them, these shocks would have to be stiffer than the shocks that were on here. These shocks originally attached back in this area, so they didn't have this extra leverage acting on them, so they could be softer than these. And of course, I probably could get a hold of Progressive and do some research and figure out, how many pounds of pressure needed to be on the spring, etc., etc., etc. But for a couple of other reasons, I decided not to do that. And the other reasons being this. One of my design considerations was I wanted the swing arm to be parallel to the bottom of the frame. And to do that, I had to use shocks that came with the bike. And I think they were 14.5 inches. Let's see. Okay, so here's the shocks that came with the bike. And yes, the bike had a hardtail on it. But the owner threw the shocks along with a bunch of other parts into a basket and saved them. And these are 14.5 inch shocks. And yeah, they look pretty nasty, but I don't see any oil leaking out of either of them up at the top. So I'm going to take these apart, paint them, powder coat it, and I'm going to use them. I got new rubber doodads for the top and the bottom, so these are going to be okay. But anyway, in order to get the swing arm to sit parallel to the bottom of the frame with these shocks installed, the shock mount hole has to be here instead of here. But I think there's enough adjustment in these old shocks to compensate for that. as far as the ride quality, which there's not going to be much ride quality with those shocks anyway. But anyway, the two shocks, the distance from the axle the swing arm pivots on to the axle the wheel rotates on both of these is about 18 inches. About 18 inches. So for all intents and purposes, the geometry of these, although not identical because I'm moving this hole, is going to be very close to the same. These are the brackets I've come up with for mounting the shocks to. And I was a little concerned that if I hit a big enough bump going fast enough, and I just had a tab welded right here, say, that the leverage acting on the shock would just fold the swing arm up and it would bend. So I'm trying to distribute the load as evenly as possible all the way back to the axle, which is why these are shaped like this. I've got it off of the bike right now. I'm going to put some tack welds on it. I want tack welds that are secure enough so that I can roll the bike around on it, but in case I run into some kind of snafu before I do the final welding, I can just cut them off and move them or remake them or whatever I got to do. So that is that. Now, having done all of the shammering about swing arms and shock mounts and shock absorbers, I'm going to confuse the issue a little bit more. Okay, tucked away under a cover here is a 65 XLCH, no, excuse me, a 61 XLCH, I believe to be very original. Not 100% original, but very original. And when I was getting ready to do this project, I measured this swing arm. And from the pivot point of the swing arm axle to the rear wheel axle on this bike is 16 inches. So the early CHs had much shorter swing arms than the later CHs and Hs. Where the cutoff for that was, I don't know exactly, but anyway, they're different. And when I originally got that square swing arm, I was comparing the length of that swing arm to this swing arm. And I thought, well, hell, I'm going to have 2 inches extra swing arm to play with. Well, I really don't, because the swing arm that would have come with the bike is 18, and the one that I want to put on there also is 18 from the pivot to the axle. So that's going to change. Well, it's probably not going to change what I'm going to do, but if you were mixing and matching one of the later swing arms to this bike, for example, it'd move your wheel 2 inches back, so you'd have to move the fender 2 inches back to keep it centered over the wheel. And I often tell guys, you can't change one thing on a motorcycle. If he says, oh, I want to put a longer swing arm on here, I'll just put it on. Well, yeah, you can put it on, but then the fender won't fit, the fender struts won't be right, the chain's going to be too short, the brake rod's going to be too short. You know, it always affects several things. But anyway, just making you aware of different swing arms floating around out there. Okay, obviously this is not a welding table. I don't have enough room for a full-size welding table, and I really don't do a lot of framework. But I do want to. Well, I got this clamped down to a piece of 3/4 inch steel plate. I don't think these tack welds are going to put enough heat in this to distort anything, but just in case. And when I do get around to actually welding it, I am going to clamp it down on this plate, and I'm just kind of testing out the arrangement of how I might do it, because when you're welding these whole continuous seams here, you're going to be pumping a lot of heat into this thing, and there's a good possibility that it could warp. So this is just kind of testing one of the possible setups. But anyway, we're going to go ahead and see if I can't get this welded a little bit. All right, finished tack welds. Does anybody notice anything different about this? Yeah, I welded them on backwards the first time. Hence one of the reasons for tack welds. You could cut them off fairly easy. Fix your first fuck up. And this is, well, this probably isn't even the first fuck up. It's probably one of many that's coming. My first welds I noticed, my tack welds, I had undercut and they weren't very good. Turned the amps up a little bit and put more rod in and I got better welds. I also used this threaded 5/8 rod to help get the alignment between the lefty and the righty. But anyway, we're going to go do an experiment now. So here's the experiment. If you watch YouTube machining videos, there's quite a few people who have devoted quite a bit of effort into making a tool that cuts from the opposite side so that the force exerted on the tool is going up instead of going down like it would be on this side. And some people have made quite complicated tool posts and setups and all kinds of things to do this. This I made many years ago to get rid of the compound, to get all the slop out of it, and it does help quite a bit. But essentially all I did was turn the tool upside down and put the tool holder in from the opposite direction. This is my tool height gauge, and I just set the tool so that it is a little bit above the center. And you want it a little bit above the center, because if it's below the center, the workpiece is going to hit the side of the cutting tool. You don't want it to hit the side of the cutting tool before the tip of the cutting tool engages whatever it is you're working on. I'm going to use a 1, 2, 3 block to ensure the tool is square to the workpiece. Okay, and this is a Sportster rear shock mounting stud, and it's a little longer than it needs to be when installed the way I'm installing it, so I need to make it about 1/4 inch shorter. And that should pretty much do it. I'm going to put just a little tension on the gib just to take as much slop out of the system as I can. So let's see if this works. This is a pretty stout piece of material too. I think it's probably equivalent to a grade 5 or grade 8 bolt maybe. Get a little oil on there. Cut it like butter. Very happy with that. Couldn't be any happier. That worked great. So as long as I got it set up, let's just do the other one and see how it works out. That worked great too. So to all of the guys on the internet who spent hours and days building special fixtures and yada yada yada, you know, somewhere between the theoretically perfect and I just have to get it done. Well, this is the, I just have to get it done. You know, this was an extra 2 minutes to set up. Maybe not even 2 minutes. Worked great. Very happy with this arrangement. If I'm parting, you know, standard kind of things, you know, thin wall tubes and shit like that, I'll probably just use the conventional parting tool setup. But if I got to part something tough, this is going to be the go-to way. All right, well, I've been dicking with this thing for a long time. Well, off and on over probably 3 weeks, several weeks. But anyway, there you go. Shock absorbers where I want them. Swing arm parallel to the bottom frame rail, parallel to the ground. Of course, this isn't the purpose of this. The purpose of this was to figure out where the swing arm and the wheel would be when the shock is all the way crushed. So, let's crush this shock all the way. I guess compress would be the more proper term. Measure it from center to center, and I'm going to make a steel bar, piece of wood, I don't know, something to stick over the shock strut mounts so that I could see the position of the swing arm and the wheel when the shock is compressed all the way, and thereby ensure that the wheel doesn't hit the fender when I'm bouncing down the road. And yeah, I know it's dangerous, and yeah, I know this could come flying out of there at 9,000 miles an hour. I put the roundy part this way so that hopefully if it does slip, it'll bang into the sides of the press and not come shooting out at me. Okay, that feels like it's probably all the way compressed. And compressed, it looks like a little less than 12.5 inches. So I'm going to make something that's 13 inches long to take the place of the shock absorber for test fitting the fender and such. So there you go. Old hunk of square steel tube simulating the length of a compressed strut. Now, as soon as I get the wheel cleaned up and the tire put on, I can figure out how to make the ass end of the motorcycle. Men, if you like this channel and this content, the single most important thing you could do to help grow this channel is to hit the subscribe button. I also have new design coffee cups and stickers available. You know, I like the old coffee cups, but I like these new ones even more. Links are included in the description down below. And for those of you who really want to go the extra mile, you could join me on Patreon. Link is also included in the description down below. And to all of you who have watched these videos, I'd like to say thank you. Thank you very much. I really, really do appreciate it. We'll see you next time. Bye.